This is based on confidentiality of the key, and key distribution faces the same threats as the encrypted data. So brute force attack is always possible, at least theoretically. So semantic key algorithms are really not people are saying that now they have lived their life and we need to really phase them out. And in public key systems based on computational complexity, say you have the RSA, which is based on the factorization of large integers. Now, what is happening is we are not able to find the large enough primes, and on the other side we are able to find more and more efficient factorization algorithms. So earlier, if in fact the same factorization was going to take some more time, it's now happening within hours and within days. So that's the problem. Discrete logarithmic like the Diffie-Hellman key exchange, these are also not secure. So we require some new paradigms actually.
This is a demonstration of Wirecast.
So enhanced computing power coupled with more sophisticated algorithms and methodologies, conventional encryption provides only limited security, termed as computationally secure algorithms. So today if we see what we are really talking of, there are two terms we call it the value of information and life of information. So what we want is that if the cost of retrieving the data is more than the value of the information and time taken is more than the life of the information, then we say that it's okay, this is secure. That's what the computationally secure algorithm is. But what now we need is unconditionally secure encryption and provable security, that we can prove the security to be a perfect security. Let us define these terms formally. That's what the definition of the provable security is. That no adversary exists that can break a key. That's what, it's very straightforward. But unfortunately saying is easy than doing it, because we need to prove it mathematically and convince the world that yes, the security of this particular system is provable. So what we require is capabilities of the attacker are defined by an adversarial model. So new models are required which will define the capacities of the adversary, which are now emerging. New models are emerging, and the aim of the proof is to show that the attacker must solve the underlying hard problem in order to break the security of the modeled system. So, unlike the earlier case where the only attack which was being considered was the brute force attack, now brute force attack we really cannot say, because the brute force attack was based on the simple assumption that the not sufficient computing power is available. Now that assumption is really not valid in today's era, so we need some more data. So we now need a new paradigm on security notions also, that can we define the security in some other ways. Okay, so the fault models, what we consider these days are two basic fault models, that computationally bounded adversary and computationally unbounded adversary. Computationally bounded adversary is one which has some limitations on its computing power. That okay, we can make some assumptions that he has a system which can execute that many instructions per second. Whereas in this model, computationally unbounded adversary, we cannot make any assumption that what kind of computing system he has. So basically, if we take this model into consideration, this is something like an unconditional security. That whatever be the computing power available with the adversary, he will never be able to break the cipher. Now, similarly, there are fault models in terms of corruption abilities. This is the passive adversary which we are more familiar, and whether the passive adversary is one who only has access to the information in the form of eavesdropping. It will capture it, it cannot modify it. Whereas active or malicious or Byzantine adversary can modify the information also. This is another one actually, what Professor Ito was talking about, the adaptability. That a static adversary is restricted to choose the set of dishonest parties at the start of the protocol and cannot change this set later. But now what is happening is a new model, that is the adaptive adversary, defines that okay, he is going in the wrong direction, he can change the direction and come to a starting point again. So can choose its set of dishonest parties at any moment during the execution of the protocol. So this is changing the whole world of encryption. Okay, now this is what the new paradigms are, these two are the most recent paradigms which we will be talking about. That the information theoretic security, that's perfect security. The system is very simple. That probability of encrypting P1 with K and probability of encrypting P2 with K, P is stands for plain text, are equal. So that P1 and P2, two different plain texts, will take the same ciphertext is equal. So unlike your earlier symmetric encryptions where each one of them will take only one of the values, P1 will map to C1 and P2 will map to C2, as long as this key is the same. So now we are changing that paradigm that okay, P1 and P2 can map to the same ciphertext with equal probability. That's what the information theoretic security means. And then unconditional security, we have already discussed that its system is unconditionally secure if it makes no assumption about the resources, whether it's the computing power, the memory available to be adversely. Okay, there are a few more. I'll just skip and come to the proof models. Actually, these are the proof models. That is strongest security model, which does not make any assumption of our proof of security. And then this is important, random oracle model, where what we assume is that there is a miracle machine which can decrypt anything within a fraction of seconds, and return the value. Okay, so a random oracle is an abstract black box that generates truly random numbers, and an algorithm is secure in the random oracle mode if it assumes the existence of a random oracle for existence of its security. Okay, now that's what I'll be discussing more about actually, and I wanted to discuss more about. These are the 5 new paradigms which are emerging. Maybe a few more, and I might have not read about them. But these 5 I have read about, and what I am presenting it here. That is information theoretic security. Though it's secure, it provides you security, but it doesn't have any kind of encryption. So no encryption, there are no keys. The only thing is then how it will achieve it. So it is still an abstract idea, people are still working on it. It works on wiretap model actually, and how it's still the research is in primitive stage. We will see what it is. Then homomorphic encryption. Here we are making some contributions in this area. Attribute based encryption, again it's basically that your name becomes your key and not name alone actually. There are so many other attributes which we will take. The DNA cryptography, that's quite recent, and this is what the people say will be the future, that's a quantum cryptography. Let us understand each one of them. See, this is the classical system. We have the encryption with the key and we have the encoding. Now in information theoretic security, we are combining them both into a single step and we call it secure encoding. So encoding itself is secure and it doesn't require any kind of key. Okay, let us see. So basically what happens is Bob has a battery view. This is Alice, which is encrypting the data, and this is Bob. Now in case of information theoretic security, it assumes a side channel or a trap or tap channel through which Eve gets the data. Now but Eve has very means either very small information, so it's not sufficient for Eve to really get any kind of data. This dot you can call this to be data. So it has really insufficient information to get any kind of useful information from the encrypted data. So basically reliability is, the goals are reliability, that is legitimate receiver successfully decodes the information, and security reads documents obtains as little information as possible. Whereas here, that's what the data rates are unchanged. Data rates are unchanged, and we try to maximize the data rates. And this is what it achieves both, that is the security as well as the reliability. Otherwise, in the conventional system, what we require is we require two separate stages. So can we combine them into a single one? Okay. So basically, let me see what. If you see, this is what we need to do it. Actually, it doesn't does not depend on secret keys because it doesn't require the keys, so no key management is required. You might recall that in all symmetric encryptions, key management is a big issue. So we don't require that kind of key management here because no keys are involved. Okay, and this is what is the achievement actually. The potentially has significant lower computational complexity. So with lower computational complexity, it is assumed that people will be able to implement this system on mobile systems also. So that's what we promised by this technique. Now this is an area which is basically it required because of the delegated computing on clouds, and that's where we are also making some contribution and trying to make some contributions here. Now basically, it's in the case of delegation of computations, what happens is currently is that even if you have the data encrypted, at the time of computation you require to decrypt the data, and computations will always take place on plain text. The question is, can we really carry out the computations on encrypted data? That's what the homomorphic encryption is all about. So what it does is basically it converts the data, it encrypts the data, and then the computations are carried out on encrypted data. The receiver, the user will get the encrypted data and decrypt it, and the result will be the same had he computed made the computations on a plain text. That's how the homomorphic encryption works. And this is also really an area which is promising to be useful. In fact, before Gently, nobody thought that it will ever be realized, but now people have started thinking that okay, it's getting realized. But what it does is, for its security, it depends upon what is termed as the noise, and to remove the noise, it requires bootstrapping. Bootstrapping is basically we need to decrypt and then re-encrypt the data. That's what is the bootstrapping is. So this is a very complex operation. It's a complex operation. So can we remove this bootstrapping? That's one thing. One of my students has been able to make some contribution in removing the bootstrapping, but that's only this is here. This is where the another problem is that even till date we are able to do these operations only on bits and not on integers, on single bits. Okay, so escape work only with bit operations, and extending them to integers is still not happened actually. And if we really want to realize them, then we need to make them work with integers at least. Okay, and symmetric versus public key is still a key-based system, and both kind of systems are in place, whether you will require public key or you will require a symmetric key. We are working on symmetric keys. That how can we really achieve the homomorphic encryption with symmetric keys. So key management is still required, even if it's a symmetric key based. Then this is another field which is really catching the attention of the researchers, that the attributes based encryption. One can encrypt according to some policy. So far what we have is the keys. Now there is no longer a key, but the attributes attached to the database itself, that we can have some kind of set of attributes which defines the key. Okay, so and there are two flavors of this. One is key policy ABE and ciphertext ABE. In key policy ABE, key is associated with a Boolean formula. That is what we have is we have some kind of relations between those. And in ciphertext policy, roles are flipped. Now, open issues here exist. That is encryption time with the scale with the number of attributes assigned to the ciphertext. So can it be achieved in some constant time? That is still to be worked upon. Not many people have been able to achieve the constant time algorithms here. Then key generation time will scale with the size of the Boolean formula ascribed to user's private key. If we increase the number of attributes, then the key generation time increases. So can we make it a constant time key generation?
This is a demonstration.
Now this is one work which really happened only few years back. That is, he was able to hide the information in the strands of the DNA. the researcher was able to do it. And the advantage was that even hundreds of terabytes of data could be stored in a very small portion of the DNA itself. Okay, so it requires very little space to store the data. And then because it's hidden and the sequence can be changed, so that works as the encryption here. So DNA provides a much more compact storage media and an externally small amount of DNA suffices even for use one-time pads. So, but the problem is people are still not satisfied. People do not have the confidence that it is unbreakable. Okay. And this is one which was something ahead of its time actually. It was 1971 that it started, and unfortunately it was accepted only in 1982. That yes, something people should consider this. So basically here what we do is we have the light, and light is polarized in one or the other way, and so polarized light is used to transmit the information. And the beauty of this is it's not possible to tamper with masses and sand using light waves without changing the properties of the masses. If somebody even eavesdrop and capture some data, then the properties will change. Say the orientation or the polarization plane, the polarization direction will change, and so you really cannot decrypt it correctly. So the data becomes useless for the receiver, and so you can detect that the data has really been played with in transit. So what people are now working is, because it's quite complex and not many, it's quite expensive also. So what they are doing is, quantum properties are ideal for key distribution. So they are using quantum encrypted cryptography for distribution of the keys. And what the people are looking for, and what we really need to bother about, what we can research upon is, research is needed to verify the security of quantum transmissions from source to receiver. It is still to be verified, and people are still not very confident that yes, it provides you the kind of security we are looking for. And then this problem, that is still we are using very small portion of the photon energy, that is only 0.1 photons per bit are thought to be secure. But it has been shown that eavesdropper armed with foreseeable but not currently available technology will be able to successfully intercept these low-level signals. And if we increase the photon energy, then we have the complications of really dealing with how to deal with that kind of. Okay, so I conclude with this, that the complexity of the threat to the information is rising. We need to understand the threat. It's a real threat actually. And new systems are needed to address the security concerns in the present era. And this is what the important aspect is, that it's a completely new complete paradigm shift from computationally secure algorithms to either information theoretic security or unconditional security, which is something like one-time pad, and really transmitting the pad from source to receiver is still not possible. So can we really achieve these kind of the kind of security which we need in near future? Thank you very much for listening.
Thank you so much, sir.
Okay, thank you. I have one notion actually whenever I teach in the class. If there are no questions from the audience, then there are only two possibilities. I will discard one later on. Either the lecture has been understood by all, or it has not been understood by anybody. Okay, and the probability of the first option is not that large, it's very small. So it's the second one. Yes, please. You have some question? Yeah, please.
Sir, from your presentation I didn't understand if the quantum cryptology is possible or not.
No. See, quantum cryptography theoretically is possible. The question is, can we, because the technology is still in its nascent stage. It's in very initial stages. So we don't have the equipment. So the more work is going on. Can we devise those many states which are possible theoretically? See, you have the polarization. Okay, now so far what we have is, we have polarization only in 2-3 directions possible. Now, if we have polarization possible in only 2-3 directions, then it's not possible to call it a secure polarization. So, is it possible to have those all theoretically infinite polarization states? Can we realize those?
Sir, question is it even possible to decrypt it?
No. See, once if encryption is possible, then decryption will definitely be possible. See, you have a polarized, suppose a polarized, which can polarize in say at 90 degrees. We have the kind of equipments available which can rotate it again by 90 degrees to bring it to its original state. So once it happens that we can have all those infinite possibilities realized, then we will have the other polarization also possible. Not still very convincing. Okay, you talk to me offline. I'll convince you.
This is a demonstration of Wirecast.
Any more questions, students? Thank you so much, sir. Thank you, Professor Ida. It was a very interesting session. I think it was most important and most interesting topic for the students, artificial intelligence and gaming. And thank you so much, C.P. Gupta sir also.
And for another session for oral presentation. In this session, we'll have 4 oral presentations. Each will be given a time of 5 minutes.
And to judge these oral presentations, I will request Professor Ida to please join the stage with Ms. Gupta ma'am and Dr. Gupta sir. And students, our first participant is from Japan, and to welcome him, we'll welcome with him a big round of applause, Naoki Sato. Naoki Sato, please come up on the stage for your presentation. To all the 3 judges, you have been provided a judgment sheet.
This is a demonstration of Wirecast. This is a demonstration of Wirecast. This is a demonstration of Wirecast. This is a demonstration of Wirecast.
Hi, nice to meet you. I'm Sato from Japan, and I'm researching about game AI. There are many games. Do you know video games?
This
In
is a
some games,
demonstration
you
of
can play
Wirecast.
with computer player, and that is AI player. And we research to enhance the performance of these AI players for to make such AI players more enjoyable for a human player to contribute to the human enjoyment. Yes. Many researchers have researched about the computer player, including chess, and chess program deep group is more strong about the human advanced player, and there are many other video games about action video games, and these are many types of games like first-person shooting games or some fighting games, and in these games, game AI is not stronger than the human player. This is a screenshot of a fighting game.
This is a demonstration
In this
of
game,
Wirecast.
sorry, video is not working, so but that is a two-player game, and there are some games, and each player control one of the character and make fight against each other. And this is a real-time game, and space game state changing
This
frequently.
is a demonstration of Wirecast.
But this fighting games is difficult for AI player because some possible actions contain some relationship, triangular relationships among them, and kick attack is effective against throwing action, and throwing action is effective against guard action, and guard action is effective against kick action. And such kind of triangular relationship make such fighting game AI difficult. And there is a cognitive delay for human players in the fighting games because that is a real-time games, and and the game set changing frequently and very minutely, so the ordinary three such approach is difficult in these games.
This is a demonstration of Wirecast.
So I will introduce about some existing approaches. As first, learning-based AIs in fighting games. They use online learning techniques to fight with human. They estimate the environment system like a state transition or reward from the transition, or estimate the opponent's action pattern like opponent modeling, and express the estimated patterns of the player. And this player can fight adaptively against current opponents. That is the advantage of this player. But this player has some drawbacks, and I will omit the detail, but this player tends to execute some very simple action patterns.
This is a demonstration of
They
Wirecast.
rarely use powerful sequential actions, but they tend to associate one action, one atomic action to one game state. So that is a drawback of learning AI. And second approach is rule-based AI that works with the if-then rules by the heuristic rules, and that takes the effective sequential action by heuristic coding. But their action patterns tend to fix because they are heuristic rules. So easily to be exploited. That is a drawback. So the purpose of my research is implement an AI which combines the advantages of rule-based AI and learning-based AI. That is our approach overview. We prepare some multiple rule-based AIs, and each of them heuristic coded and make powerful action patterns, but their action patterns are fixed. And one by one, the proposed method tries the inside rule-based AI against the opponent player. That is the online process. And after that, the most effective AI player fight against the current opponent for a long time period. And if the opponent player changes their strategy and the selected AI player becomes useless against the opponent player, in that case, our proposed method again try each inside rule-based player one by one and decide the most effective AI, and the effective AI fight against the current opponent for a long time. In this way, our proposed AI can use some heuristic powerful action patterns of the rule-based AI, and at the same time, our AI has some flexibility, adaptivity against the opponent player by picking out the effective rule-based AIs. And so, how do you decide the most effective AI? What is the most effective AI against opponent player? We can observe the amount of damage during the fight period, but sometimes not effective AIs may cause large damage against the opponent player, or vice versa. Some very effective AI might cause very little damage against the opponent player sometimes. So the process is some stochastic, including some randomness. So we apply some mathematical UCB algorithm to decide the next AI player chosen from the proposed method. Sorry, we don't have much time, so sorry, I will omit the detail, but our method try to maximize our expected reward, and reward is the amount of damage. That is our definition, and our method try to always maximize the expected reward from the fighting process.
This is a demonstration of Wirecast.
That is some detailed explanation, but sorry, I will omit. And we did an experiment in some one minute. We did some experiments in the fighting ICE platform, that is a platform for fighting game AI, and our proposal method obtained the highest score among them, and that is a learning curve, learning history. The borderline is sorry, I will omit the details.
This is a demonstration of Wirecast.
Our proposed AI obtains the highest score.
This is a demonstration of Wirecast.
Thank you.
This is a demonstration
Now,
of
our
Wirecast.
second participant group for the oral presentation is Devesh Yadav and his group. Devesh Yadav.
This is a demonstration of Wirecast. This is a demonstration of Wirecast.
Processing architecture using graphical processing unit in finance. According to Moore's law, the number of transistors in the dense integrated circuit will double after every 2 years. So there will be a limit in the miniaturization of the transistors. So to increase the computation, parallel processing is used. So one of the most effective processors uses the parallel processing. GPU has used the parallel processing, graphic processing unit can be used, and GPU has emerged as a massive parallel architecture for fulfilling the large computation requirements. So what are GPUs? GPUs are designed to speed the architecture, to speed the texture operation, which is so essential in advanced 3D graphics. So they have very high arithmetic intensity. The engine of GPU has been simple and easy to replicate to reduce data parallelism. And GPUs can be used in financial simulation, image processing, modeling, and various other fields. CUDA architecture, which is especially implemented for GPUs, can be used for this process.
Hello. Good afternoon. So let's do literature review. Literature review first. The author, Jerry Hong, experimentally shows how parallel processing is better in terms of time and calculation than sequential processing. He analyzes the risk and the price associated with computational finance. And with his experiment, he shows that using a software PixGrid, which runs on Java libraries, and he shows that using 140 systems on PixGrid, he can decrease the time by in a multiple of 90. So suppose a process used to take 90 days for its completion. Using parallel processing, we can accomplish it in a single day. Secondly, this review. The author, Ilgard Ziad, shows the demands and talks about the needs of parallel processing in finance. He talks about how financial activities such as portfolio management, intraday trading, which requires time series analysis over big data to capture the needs, patterns, series so that we can take an informed decision. When we talk about trading in finance, nowadays a new kind of trading is taking place. High frequency algorithmic trading. Usually in trading, if you implement your algorithm as fast as you can possible, you get the more benefit, more profit. So with that, using parallel processing, you can implement the algorithm in a nanosecond. So these are the scenarios where you can see the worth of parallel processing. Picture review 3. The author Gray compares the GPU library code with CPU library code, normal CPU. And he proposed GPUs in Quantilib, a library written in C++ specifically for quantitative finance. And he proved that GPU libraries are better than CPUs, normal CPU libraries, by examining by using the quantitative applications on financial formulas and instruments such as Black-Scholes formula, Monte Carlo, bonds, and repo rate.
Wirecast.
Thank you. And I hand over the presentation to Mr. Kaushal.
Thank you, Davish. As you all heard, that parallel processing is increasing the speed of our computation. But what we don't really know is whether it's really important. Financial world today employs high-frequency trading. High-frequency trading uses millions of dollars of transactions within nanoseconds. And this shows how time-intensive our applications really need to be. And for this, we need better algorithms, and also with better algorithms, we need better architectures which parallel processing provides us with. The computational power of private computers that firms use today are just not sufficient enough. They also have had an option to change their computation power to supercomputers. However, that was not found to be cost effective, and thus came parallel processing. Recently, practitioners and mathematicians and engineers are engaged on to harness the optimum powers of parallel processing.
This is a demonstration of Wirecast.
Researchers from domains and trade are finding parallel algorithms. Algorithms up till now have already been developed for sequential processing. In order to employ the optimality of parallel processing, we need better algorithms designed specifically for parallel processing. This was actually a survey study. Which you finally compared between parallel processing and serial processing. Parallel processing was definitely faster than serial processing. This also decreased the wait time for processes. Parallel processing architectures were built on the notion to be scalable and thus can employ better future applications. There was also the most important part that came out, surprisingly, was the accuracy, which was not expected. Accuracy because when we perform forecasting methods, the greater number of data that we can study gives the better accuracy. Because parallel processing was faster, it was also more accurate. This was the surprising result that we got.
This is a
In
demonstration
conclusion,
of
I think that
Wirecast.
using parallel processing architecture, we have not only speed but also accuracy and scalability. Yet, we do not have efficient algorithms which can totally use or harness the optimal power of parallel processing. However, our hardware architectures also are not specifically designed for parallel processing, since we still use the traditional or conventional methods of serial processing.
This is a demonstration of Wirecast.
Thank you, students. Now our next researcher, Ms. Payal Sharma and Mr. Rajat Kumawat. Students, kindly take care for the time constraint. You have to complete your presentation within your time. And next will be Hashim Mahmood and Anand Pahuja. I request them to please come nearby the stage.
This is a demonstration of Wirecast.
So, good afternoon everybody. So today's my topic is application of parallel computing and mobile computing. So let's first start with the basic definitions of parallel computing, why there is a need of parallel computing and mobile computing. So let's first start with the definition of parallel computing. So parallel computing is a form of computation in which many problems can be carried out simultaneously. So this image easily depicts that a single problem, which is a larger problem, is divided into discrete parts, and those parts are multiply processed in different CPUs. So why we should use parallel computing? Because it saves time and cost, solves larger problems, it has concurrency, and it uses non-local resources. So what is mobile computing? Mobile computing is a technology that allows us to transmit data, video and voice via computer or any other wireless enabled device without connecting to a physical link.
This is a demonstration
So
of
why we
Wirecast.
should use mobile computing? The need for information anywhere, anytime has been a driving force for increasing growth in web and internet technology, wireless communication and portable computing devices. So mobile computing techniques are essential for enabling distributed and non-centric applications which require remote and ubiquitous information access. So the application of parallel computing in mobile computing. So let's first discuss the application of parallel computing in mobile banking.
This
So the
is a
parallel processing of
demonstration
credit
of
card
Wirecast.
transactions will perform with the help of a grid network. So what is a grid network? Grid network is a network in which multiple computers are connected. Multiple computers are connected in a network. So what with the grid topology?
Next application lies in the mobile search engine. As you all know that the large amount of data is present over the internet. If we use serial computing other than parallel computing in that accessing those data, then it might take a long time. But if we use parallel computing, then the results will be much more effective. Another application lies in the multimedia application. Everybody uses multimedia applications in their phones. Those applications make use of parallel computing. Few examples are face detection applications and image sub-pattern search applications. Now, we've made a comparison between serial computation and parallel computation on the basis of the various fields of the mobile. What we conclude is, in case of the mobile banking, due to parallel processing, a very quick response is guaranteed to the user, irrespective of number of requests available to server to process. In case of serial computation, if the number of requests are large, then it might lead to denial of service. Multimedia applications run much faster when parallel computation is used other than the serial computation. Computing in terms of both response time and energy consumed on the mobile device, then parallel computing gives much more efficient results as compared to serial computing. On incorporation of parallel computing in mobile computing, requests are processed quickly and in accurate manner. Therefore, at last, study concludes that parallel processing is an important feature in improving computation power of the mobile. Thank you.
Any queries, students?
This is a demonstration of Wirecast.
Our last presentation for this session, Mr. Hashim Behbood and Anand Paluja.
This is a demonstration of Wirecast. Of Wirecast.
Well, good afternoon everyone. I am Anand Paluja. Together we are going to represent our idea of magic blend in mobile systems. So, as the picture depicts, these are the smartphones which we use in our daily lives. For what activities do we use? For playing games, for telephonic conversations over wireless networks, etc., etc. Now, my question is, what these smartphones consist of? What makes them so attractive? What is the basic feature implemented in these apps? The answer to this question is OS, which stands for operating system. The operating system is usually an interface which acts as an interface between the user and the machine, so that user finds everything useful and user finds everything in a systematic manner, so that he or she can accomplish his tasks easily. The kind of OS which we will be dealing with is modular OS. Now in modular OS, what happens is all the functionalities are implemented in separate modules, with the kernel implemented as a separate module too. Now the benefit of modular OS is that if an update is to be made
to OS, then only the appropriate model needs to be updated, not the entire OS, which saves a bunch of time in recompiling, which saves a bunch of time for recompiling the OS. And whenever a user wants to add use the functionality of the OS, what the kernel does is it dynamically links to the appropriate module so that user can use its appropriate feature properly. Now I would like Kashin to move ahead. Thank you.
Hello everyone. So the next thing that we are seeing is cloud. So what basically is cloud? Cloud is nothing but a framework of services that is provided to the user so that the user can basically use computational powers of some other processor, store data somewhere else in a remote server and use that feature on his own computer. So basically the main thing that we are seeing is what is this? A blender. A blender is nothing but it mixes a lot of things. As you can see, chocolates and sauces are getting mixed. So what we are doing is blending the operating system into our cell phone with the cloud. So the idea goes like this, that the main kernel will be in the cell phone and the other modules that are in the modular OS will be somewhere in the cloud, somewhere same. So whenever the user wants to use these functionalities, the OS will dynamically link those modules in the cloud and use those modules from there. So that will decrease the amount of space, amount of hardware that is required for the cell phone, and the cost of the cell phone will also be reduced. Also, there is one more thing that will be helpful for the user, that is the amount of space that the user needs in his phone, that is the secondary memory. As you all know, how much it is hectic for you all when your phone shows out of memory. So the phone will never show out of memory. You can click as many photos, keep as many videos as you want, and keep on running the cell phone. The results would be that the operating system will need fewer updates. Means only the kernel will not be needed to be updated frequently. Only the modules will be needed to be updated. Then more features with less restrictions. Means we can keep the cost. We can spend cost on other aspects of the cell phone, like cameras, like screen size, and other things. So the user will get more hardware features that he is getting right now in less cost. And then less money spent on secondary storage, because we don't need too much of secondary storage, because the storage will be on the cloud, and then losing a cell phone will not mean losing the data, because the data will be on the cloud. If you lose your cell phone, your pictures are not gone. You can sign in your cloud account, and then from there you can retrieve the data in your new cell phone. And the last thing that is that the basic features of the phone is still intact. What if the cloud fails? What if you are not connected to the net? What if you are in some jungle? There also you can make calls and you can see 1-2 photos that is there in your cell phone. Thank you. And at last we have a happy customer.
Everyone is very tired? Okay. Thank you so much, students. Now I would request Professor Manish Bhyani sir and Professor Akagi to please present a token of remembrance to Dr. C.P. Gupta sir. So can you please come up on the stage? Dr. C.P. Gupta sir has travelled all the way from Kota to here, and he is an associate professor in RTU. Professor Akagi, please join.
This is a demonstration of Wirecast.
Give them a big round of applause, students. Students, now we have another session that is for poster presentation. And for the participants, one more thing. Now I would request Manish sir and Professor Akagi to present a token of remembrance to Professor Ida sir. Professor Ida. Professor Hiroyuki Ida is here for BICON 2015 also. Students who has participated in the poster presentation kindly move to the poster presentation area, and the judges for poster presentations are going to be Professor Ida, Dr. Kavita Chaudhary ma'am, Dr. C.P. Gupta sir, and Dr. Manish Biyani sir. So I would request our volunteer to please give them a judgment sheet for the poster presentation, and rest of the students can move outside in the lawn area for the refreshment. We'll back here in after 20 minutes. Yes, just after.
This is a demonstration of Wirecast.